Hello, boys and girls. Happy Saturday. What we're going to do today is I'm going to give you a solving radicals with Miss Trejo. Okay, you're going to go ahead and put your name, period, date. Today's date, I guess, is the 7th or the 8th. I'm not sure. But you're going to use this video to complete the in-class practice. So we did this in class. I gave you guys this handout and we were solving the radicals with our clock buddies. Remember, we were rotating around the room with different students and helping each other out. Now, not all my class periods got to finish these notes, or got to finish this page. So if you didn't finish this page, you're going to use this video to help you finish this page. If you did finish this page, then all you need to do is write down your notes, okay? So I'm going to go ahead and give you a bunch of problems. They're going to be very similar to the ones on your worksheet. And these are some good practice problems, okay? So number one is going to be just like number one. Our problem is b minus 3 is equal to the square root of b minus 1. I'm going to go ahead and zoom in as much as I can so that you guys can see this nice and big on your phones. The first thing you need to do is get rid of the square root. So what do I need to do to get rid of the square root? That's right, I'm going to square both sides of the equation. When you square the left side, make sure you add parentheses on that, okay? So now you have b minus 3 squared is equal to the squared and the square root cancel, so you're left with b minus 1. I need to simplify, or I guess FOIL, the left side. So that means I want to multiply b minus 3 times itself twice. Now, some of you guys like the box method. I like the box method too. I think it makes our life easy. So we're going to put b minus 3 times b minus 3. What's b times b? B squared. And b times a negative 3 gives you negative 3. And b times a negative 3 gives you negative 3b. Negative 3 times a negative 3 is a positive 9. Now, if you prefer to use x's instead of b's, that's fine with me. Okay, you're going to combine the like terms, which in this case is negative 3b plus a negative 3b gives you a negative 6b plus 9. So you can either expand this binomial by multiplying it using the box method, or you could do it using FOIL. The next thing is I'm going to move b to the other side, and I'm going to write it right underneath the b. Not that b, this b. Okay, and the difference is because this b has a b squared and this b does not. So both of them have an exponent of 1. So that's where I can subtract the b from. The next thing I'm going to do is I want to get rid of this negative 1. So I'm going to do the opposite of minus 1, which is to plus 1, or add 1. I'm going to write it right underneath the 9, which happens to be our constant. When I say both sides, I mean both sides of the equal sign. Okay, b minus b is 0. Negative 1 plus 1 is also equal to 0. Those cancel each other out on the right side. And now I'm left with b squared. Negative 6b minus another b is negative 7b, and 9 plus 1 is 10. So now I have a quadratic function. This is what we were learning about, and this goes back to what we have learned way back in the day, a couple of weeks ago. So what you're going to do is you're going to factor this quadratic. In order to factor, you're going to use your CB table. And as a reminder, remember, your quadratic function in standard form is ax squared plus bx plus c, all equal to 0, which is exactly what we have here. Okay, so what is the value of c in this case? C is the constant, it's the last number in the quadratic, so c is 10, and b in this case is negative 7. So you're going to say, what numbers can I multiply together to get 10? Well, I know it's 5 times 2 and 1 times 10. If I multiply them together and then add them together, 5 plus 2 is a positive 7. So that's not the right answer, but I know that I'm close. So I'm going to go ahead and make these both negative. And a negative 5 plus a negative 2 gives me a negative 7. So those are my factors, negative 5 and negative 2. I'm going to put b's on the inside. 1 plus 10 gave me 11, so that's why we didn't go with 1 and 10 as your factors. So now you have two possibilities. You have the possibility that b minus 5 is equal to 0, or that b minus 2 is equal to 0. In order to solve for b, you have to do the opposite of what's being done. So I'm going to add 5 to one side of the equal sign, and then add 2 to one side of the equal sign. So now I'm left with b is equal to 5, and b is equal to 2. We have solved the function. This is as long as they get, okay? But now we need to check to see if they are real or extraneous. How do we check if they're real or extraneous? Well, you have to substitute 5 back into your b. So what's 5 minus 3? 5 minus 3 is 2. And what's 2 squared? 4. And the question is that equal to the right side? The right side is the square root of b minus 1. 5 minus 1 is 4. The square root of 4 is 2. Are they equal to each other? No. So that means that b minus 5 is extraneous. On the other side, if I let 2 be equal to b, I have 2 minus 3 is equal to question mark. You know what I did wrong? Is I included the squared, and I shouldn't have. So what's 5 minus 3? 2. Is 2 equal to 2? Yes. So this is actually real and not extraneous, because both sides ended up equaling to each other. Alright, so I substitute in a 2 wherever I see a b. 2 minus 3 is equal to a negative 1, and the question is that equal to the other side, which is the square root of b minus 1. 2 minus 1 is 1. The square root of negative 1 is 1. So those are not equal. So b equals to 2 is your extraneous solution. So you had two solutions, b equals to 5 and b equals to 2. One was real and the other one was extraneous. You can use this problem to help you solve number 1. Okay, let's go to the next question. This is like number 2 on your handout, okay? Number 2, I'm going to come up with this problem. 9 minus b is equal to 1 minus 9b, and we're taking the square root of both sides. Okay, that's what we start off with. So what do we need to do first to get rid of the radical? You're going to square both sides, and you're left with 9 minus b is equal to 1 minus 9b. Well, now our job is to get all the b's on the same side. So I think it would be easier to move 9b to the other side so that we get rid of the negatives. So we have negative b plus 9b is equal to 8b is equal to 1. In order to solve for b, I got to get rid of the 9. And so now I'm left with 8b is equal to 1 minus 9 is actually equal to negative 8. If I divide both sides by 8, you get b is equal to negative 1. So our check is to substitute a negative 1 wherever I see a b. Is it true that 9 minus negative 1 is equal to 1 minus 9 times negative 1? 9 negative times a negative is a positive, so this is actually 9 plus 1. And this is 1 plus 9. Take the square root of both sides, and you can already see that the square root of 10 is equal to the square root of 10. Sorry, got cut off. So this is actually a real solution. Okay, let's go to the next question. This is like number 3. And like number 4. Okay? Well, I'll do like number 3 first. Okay, so this is like number 3. The question is 5 equals to the square root of x divided by 3. You always want to isolate the radical. The radical is isolated, so now we want to get rid of it. 5 squared is equal to 25. When I take the square root, when I square the square root, it gets rid of it, and I'm left with x divided by 3. I'm going to multiply both sides by 3 since I'm dividing by 3. You want to do the opposite of division, which is to multiply. What's 3 times 25? 75 is equal to x. The question is this real or extraneous? So you're going to put 75 divided by 3. 75 divided by 3 is 25. The square root of 25 is 5. So this is actually a real solution. Okay, let's look at, this is like number 4. Now I'm actually trying to keep them numbered the same, okay? So number 4 says solve for y. And the question is 5 equals to the square root of x divided by y. Now this is very similar to number 3. Okay, the first thing you want to do is square both sides. And you're left with 5 is equal to x divided by y. Since I'm trying to get y by itself, I think the easiest thing you could do is multiply both sides by y, just like you did on this side. Okay, so you're left with 5y is equal to x, and then you have to divide both sides by 5. So y is equal to x divided by 5. That is your solution. This is solving for y in terms of x. If you don't like that, I also recommend that you do a cross multiplication. If I multiply 1 times x, I get x. If you multiply 5 times y, you get 5y. You need to divide both sides by 5 to get y by itself, so you're left with y is equal to x divided by 5. Same answer, just 2 different ways of finding the answer. Okay, so we just finished number 4. We are going to start on number 5. Number 5 says r squared is equal to the square root of 2r plus 3. This is just like number 5, okay? And sorry, it should be r to begin with. So if I have r equals to the square root of 2r plus 3, in order to get rid of the square root, I'm going to square both sides. This is where that squared came from. Okay, so I'm left with r squared is equal to 2r plus 3. I want to get all of the variables on the same side. So instead of subtracting r squared and get a negative r squared on the right side, I'm going to actually move the 2r and the 3. So that means I have to subtract 2r from both sides, and I have to subtract 3 from both sides. Our goal is always to write the quadratic in standard form. Okay, so looking at these numbers or these terms, what would we write first? That's right, we would write r squared first, and then comes the bx minus 2r. And if you feel better replacing all of the r's with x's, that's fine with me. And finally, the constant is minus 3. So you're going to factor these problems. You want to make a CB table. In this case, what's the value of c? C is -3 and b is -2. So the question is, what 2 numbers can I multiply together to get -3? Well, this is easy. It's either 1 times a -3 or 1 times a +3. If I add 1 plus a -3, I get -2, so there's my answer. -1 plus 3 gives me a +2, so that cannot be the answer. My factors are going to be a +1 and a -3. You fill in the r's there, so I have 2 possibilities. I have that r plus 1 is equal to 0, and that r minus 3 is equal to 0. So when you solve for r, you're going to subtract 1 from both sides of the equation, and you're left with r is equal to -1 as a solution. And then r minus 3, you're going to add 3 to both sides of the equal sign and get r is equal to 3 as another solution. Our last step is to check to see if they're actually real or extraneous. You're going to substitute in -1 and see if that's equal to 2 times -1 plus 3.